Hello everyone. In this video, we will look at the problem for level order traversal of a binary tree. So we are given a root of binary tree and we have to return the level order traversal of its nodes values from left to right and by level. So for example, if we have a tree like this diagram, in that case, the first level is 3, second level is 9, comma 20, and third level is 15, comma 7, and hence we return that as our output. So if we, so for example, here I have also taken two more routes for the two more nodes for this node 9 for better understanding. And as you can see, this will be our first level, this will be our second level, and this will be our third level. So the tree traversal that directly comes to our mind when we look at these things is breadth first search, because we are going breadth first rather than we are going depth first in this case. That's why we go to breadth first search. As you know, in the breadth first search, we make a use of queue for storing the nodes, and then after pulling the node at the head of our queue, we will be adding its children at the end of the queue, and so on. Now, what we want to do here, one more thing is that if you take a look at the output structure, we have to go level by level. So the output will be like first sublist will contain 3, second sublist will contain 9, comma 20, and third sublist will contain all the remaining 4 nodes at the last level. So while doing BFS, what we can do is we will be having this queue, and we will add 3, which is the root node at the beginning in this queue. Now, while this queue is not empty, what we will have to do is pull this 3 from the queue and then add its children to back to the queue. So it will become like 9, comma 20, and here we have one list ready, which is 3. Now here we will have to keep track like for how many numbers are how many elements are present at that particular level. So for example, at the first level there was only one element, and now after adding the children of this root element, we have now two nodes at the second element. So count here will be 2. uh, we will come back to why we need to store this count somewhere, because basically we want to have sublist for that per each levels. So now after we again poll 9 from this queue, as 9 has these two children 19 and 11, we will add these two children at the end of the queue. So it becomes something like this, 19 and 11 will be added at the end of the queue. Okay. And after that, we will also poll 20 and add its children to the queue. So remaining are like 19, 11 and children of 20, which are 15 and 7. So we add that at the end of the queue, 15 and 7. And at this point, basically our output will look like something like this. We have one sublist of 3 and second sublist of 9, comma 20. And here the count will be 4. Now the count will be 4. And then again we poll everything from the queue, as this all the 4 elements doesn't have any children. All the 4 elements will be polled one by one, and then our third sublist will be like this one. So the output will look like 3, then 9, comma 20, and then these 4 numbers which are 19, 11, 15 and 7. So as you saw, basically, if we why this if you visualize this queue as a whole, let's say we didn't pull elements from this queue. The breadth first traversal will look something like this. So 3, 9, 20, 19, 11, 15, and 7. And here we need to have some kind of partitions for each level. So as you can see, our root element, there is only one element, hence the partition after first element. Now our second level, on the second level, as this root has two children and we push these two children on the queue, hence the at each time q dot size will be this. So for this q dot size, every time we will do the polling and adding these children again back to the queue. So here the queue size was 2, hence this number came as 2, and then after adding the children of 9 and 20, queue size became 4, and hence this number as 4. Now, if we take a look at source code of this, so basically we are getting the root element as the input for this level order function, and the output structure is like list of integer. So at the beginning, if the root is null, we will be returning empty list, and we will declare one result as array list, which has the type of list of integers, because we want to return this something like this structure, level by level BFS. So after that, we will initialize a queue and add a root to the queue. And while this queue is not empty, what we will have to do is take the count which is queue dot size. As we saw in this picture, we will have to take this q dot size and make the iterations till that size. So for this iteration, we will so at for these size number of times, we will perform this for loop. And in that for loop, basically before this, we declare the label values as sub array list, and in that list we will go on adding the polled element from the queue. So we poll the element, let's say popped element, and that element we will add to label values. Polled element dot val, we will add it to the label values, and then if its left children is not empty, we will add that left children to the queue, and again same, we will do the same for the right children. So if right children of that pop element is not null, we will add that right children to the queue, and then after this for loop is complete, basically we already have this list, we already have this sublist complete, and hence we will add this sublist to the our main result list, and after that we will return the result.